This conference will now be recorded.
All right, so good morning, folks. So I want to just start off here with a review of the slide that we were looking at last class. And so it's regarding stem cells. And I mentioned to you that stem cells can reproduce themselves via mitosis, okay? And this mitosis will take the parent cell and create two identical daughter cells. Now, in the case of these stem cells, then we can continue on the line of reproducing more stem cells, or this stem cells can differentiate into other types of cells. Now, we in the laboratory environment cannot take a stem cell and then reproduce, say, a nerve cell, a neuron, nerve tissue. Okay, we wish we could do this because we would love to see that different types of dementia, different types of neurological disorders like Parkinson's and multiple sclerosis. These kind of disorders can be cured or at least helped via stem cells. I know that there's a lot of research going on, folks, and there's a lot of different studies being done in order to try and do these types of things. But we still haven't been able to take a stem cell and reproduce nerve tissue in order to replace neurons, to replace damage. So if a person is involved in an accident and they sever the spinal cord, right? They sever the spinal cord at the cervical region, the neck region. Anything distal, anything below arms, legs, right? Those lower extremities and such will not function, right? Because there will be a cutoff of the communication between the central nervous system and the rest of the body, okay? If there's a severing of the cord lower, it can only affect then say the lower extremities, okay? So the person wouldn't be able to walk. Now they've been doing some pretty cool stuff, and they have technology in order to computer controlled technology in order to help patients be able to walk again, which is quite remarkable. Assisted walking, right? Ambulation. But as far as actually taking stem cells and producing nerve tissue, nerve cells and such, this is not the case at this point in time. Okay. But it'd be wonderful. They're still doing research, you know, and they're still continuing to do research in order to try and come about this. Now they have done, and I think I mentioned this to you last class regarding taking adipose tissue stem cells, right, and being able to create. It's not breast tissue, but it would still be the tissue that could fill the space where, so say a patient had a mastectomy and had one breast or both breasts removed, they could remove the breast tissue and then replace it with adipose tissue, and that those stem cells will reproduce and fill the area with. So it's going to only be, these are stem cells for adipose tissue. It'll just produce adipose tissue. It's not going to produce breast tissue, right? But it still fills the area where of the skin where the breast was previously, and the patient does not have to have any type of implant. It's their own tissue, right? They would do liposuction and create these a slurry of these stem cells that could reproduce and fill up the tissue. So that's some pretty cool stuff. This is just the image of by there showing you regarding stem cells. So now we get into different types of connections between the cells. Right now, recall that, in particular with the epithelial tissue is tightly packed cells, right? And so these cells are all tightly packed, close to each other, and we have different types of junctions, right? They knit the cells, they stop leaks, they have communication, meaning that actually there can be material from one cell moving to another cell via these gap junctions. These tight junctions, these adhering junctions, these are what help to really hold the cells together. And the gap junctions allow for, see the cytoplasm, there's movement of material from one cell to the next as a result of those gap junctions. Here you're seeing an example of muscle, okay? So what we're looking at here, folks, is that we're looking at voluntary and involuntary. Skeletal muscle, when I move when I think about it and I say, hey, I want to move my upper arm, I'm doing it because I have conscious control. It's voluntary control over the skeletal muscle. Involuntary would be cardiac muscle, right, the heart, and any type of smooth muscle present in the organs as well as in the blood vessels of the body. See how they're spindle shaped? They're kind of odd in their appearance, whereas skeletal muscles, very long fibers, involuntary muscle of the cardiac muscle itself, which is involuntary, has these very similar looking to the skeletal muscle, except there's branching taking place, and we have these intercalated discs, these special junctions that will allow for the heart muscle, the upper chambers to contract as one, and the lower chambers to contract as one. Membranes that are covering the different organs of the body and such, right? So we have the covering of the skin, which would be the epithelial tissue, and then there's connective tissue membranes that are covering all the organs of the body. And know that here, you'll see here it says epithelial membranes pair a sheet of epithelium with connective tissue, mucosa lining. So mucosa would be in your mouth, your oral cavity, would be in your respiratory system, in your nasal cavity and such. These passages are exposed to the environment and they're covered in, well, in the case of the oral cavity, it has saliva as well as mucus. And in the case of the respiratory system, there's mucus present in order to cover and line the tissues there and keep them moist. You'll have these membranes. You'll have a mucous membrane, serous, cutaneous, synovial. So let's go over the 4 of them here. So mucous membrane, again, secreting mucus, okay? Mucus is a protein, mucin, and water. That's what creates this mucus. And it's very sticky, and it's very, it's a protective type of a substance. In the case of like the stomach, mucus is present in order to prevent the acid from the stomach eating away at, taking away from the tissue of the stomach lining. In the case of, say, the oral cavity or the respiratory system, the nasal cavity and such, and present within also like the tubes of the respiratory system, as well as the tubes of the digestive system, it's just a protective barrier. But in the case of like the respiratory system, it's sticky. And so any type of particulate matter that you're breathing in, the stickiness of that mucus will connect to any type of particulate matter present that's coming in through the air that we breathe, and help to then move it out of the respiratory system so it doesn't enter the lungs. Now, in the case of, say, like someone who works without, many years ago, like those that worked in mines, right? So like coal mines, it was so much dust and material with no protection that it just got into the lungs, and just over time led to all kinds of disease and death as a result of, overwhelming the respiratory system. Serous membranes. So these would be the types of tissues that I talked about, the membrane that will actually cover the organs of the body. Okay, allowing for a covering that touches the organ, the visceral portion, and a parietal portion that is on the outer part. So it's 2 layers, paired in sheets, and there's a fluid between, this serous fluid, which allows for, I believe that I mentioned this, where if you do this, you'll feel heat, right, between your hands by that friction that's built up. Well, in the case of organs that are moving and they're covered in these serous membranes, that double sheath membrane with the fluid in between allows for the organs not to build up any type of friction, which could build up heat, which could end up causing damage to the tissues of the organ. Cutaneous membranes, we're thinking of the skin. Right? And then synovial membranes, these are membranes that are present within joints, special type of joints. When you think of a joint, you're thinking of primarily a synovial joint, a joint that, like, say, your elbow, your shoulder, okay? These are synovial joints. And so they have fluid present within, encompassed by this membrane, so that it keeps the joint, like you would say in the case of like an automobile, that we have different types of joints present, that they'll have different types of like packing, what is it called? Like lubricant, yeah, lubricant, right? That'll allow for the joints of the car to move properly, and they'll have rubber seals and such, kind of like holding that fluid in place, or that slippery substance in place, lubricant. So here we have examples of the different types of membranes. Now, as far as the body is concerned, it's comprised of these organ systems that are made up of organs, that contain organs. Now, you'll see here 11 organ systems, right? Now I'm going to show you, I'm going to give you a little helpful, yeah, there we go. Okay. All right, so when I put that there, that helps you to see that this Miss Curly Nerd. So that's just how I remember. Well, I mean, over the years, beginning when I started learning about the anatomy of the human body and such, this is one thing that I used in order to help me remember the different body systems. So if you'll see here, so it has muscular, skeletal, cardiovascular, urinary, respiratory, lymphatic, integumentary, which is the skin, nervous system, endocrine, reproductive, and digestive systems. So there's all the body systems, okay, present within a little mnemonic there that might be helpful to you. You don't have to use it, but it's just, I give it to you just so that, you know, it helped me and maybe it'll help you. You'll see here that we have these cavities that are present that house, that contain these organs present within the organ systems. So here, this is showing you the organizational level of the human body, okay? So you have the organ system, okay? Well, actually, right here, first of all, let's start with, here's an organism, the human organism. It's a human body. It's comprised of organ systems. So let's look at, say here, there's the digestive system, okay? Digestive system. Well, it's comprised of organs, many different types of organs, whether it's the intestines, we have the stomach here present, you'll have the liver, the gallbladder, right? These are all present within the organ system of the digestive system. So the stomach is comprised of then different types of tissue, right? So in the stomach itself, you can see that we have the epithelial tissue. These are simple columnar, column-shaped cells, epithelial tissue. We have here connective tissue. We have here different types of muscle and nervous tissue, all present within one organ. And then these different tissues are comprised of different types of cells, right? So you see here how we can go from the cellular level all the way up to the organ system and the organism. I'm going to sneeze, I apologize. Okay.
Bless you.
So, thank you. Thank you. So here we have an example of the different organ systems, right? So we have the integumentary, the skin, hair and nails and such, you know, and the different glands, right? Oil-producing glands, mucus-producing glands. The nervous system, the muscular, skeletal, circulatory, and cardiovascular. Endocrine, lymphatic. Lymphatic system works with the cardiovascular system to form your immune system, your immune response. You'll see here respiratory system, digestive, urinary, and then lastly reproductive, male and female. So I have set for you now here. And so the first quiz that you'll have, it'll be available on Thursday till Sunday evening at 11:55, right before midnight. Okay. So the first quiz will be on chapter 4. And so a lot of the questions will be regarding different organ systems. And so recall that I said to you that you're able to have a 3x5 card, like an index card, right? With one side, you can put information regarding a like little crib notes, okay, notes regarding the chapter, the PowerPoint, and you can take the quiz. The quiz will be 30 minutes. It'll be 25 questions, okay, and you'll have 30 minutes to take it. So it's not open book. You just have that little one-sided 3x5 card. Okay, I'm not there. I can't, you know, tell if you're cheating or anything like that, if you're doing more than just the one side of the card, but I'm trusting you that you will only write information on one side of the card and you'll be able to use that while taking the quiz. Okay. Other than also, if you step away from, like if you close out and open up another window while you're taking the quiz automatically shuts down. Okay, just so that you know that. So do not step away. Do not, as you're taking the test, again, the 30 minutes is the timer's going. You can't do Google searches. That's not allowed, right? That's not a part. That's cheating. Okay, so just the 3x5 card, one-sided, right? But I think that's pretty fair, actually. You'll see here as far as the integumentary system. So it's the skin, hair, nails, and the different types of glands that are producing substances, secretions. Okay. On Thursday, when we're doing our lab class, I'm going to go over the integumentary system, the skin, and give you some I have posted images for you to study and to know, and I posted the list for you, right? The actual word bank that you'll know that you need to know in order to identify structures when we do a lab quiz. Okay. So you'll see that the epidermis and the dermis. The epidermis is the outer layer. When you think of your skin, you're thinking of the epidermis. The dermis is the next layer below section of skin, and this is a part of really like the supportive type tissue. There's connective tissue there. Okay, so the epidermis is more of the different types of epithelial tissue. In particular, it's stratified squamous. It's different types of cells, this tissue that actually forms multiple layers of the epidermis. That outer layer is dead, and so we'll discuss this more detail. And the hypodermis, it's not a part of the skin, but it's supportive of the layers of skin. Okay. And here what you're seeing is that there are multiple levels of this epidermis, and really the outer layers do not have nuclei, they're dead cells. Okay, so look at here on this image. This is an image of the skin, and you're seeing here that these outer layers are dead cells, no nuclei present. Okay, and so when you do this and little cells of the skin come off, it's because they're dead cells and they're meant to do that. Okay, the dust in your home is primarily made up of the epithelial tissue, the cells that are coming off of your skin, and that's primarily what the dust is present within your house. Kind of a little weird, right? I mean, yes, there's dust that will come in from outside, but primarily a good portion of the dust, it's you and your family. Yes, yes, Gabriella. The quiz is multiple choice. These are just a couple of the types of cells that are present in that epidermis, okay? And then the glands that are producing sweat, that are producing oil. So the keratinocytes, or the keratinocytes, the keratinocytes, the melanocytes, melanocytes are producing the pigmentation, melanin, which will allow for our skin to have its different pigments. Excuse me. And the cells that, when I showed you here that cells are dead cells and there's no more nuclei present, they're dead. See them right here. They're filled with this protein called keratin. Keratin is a protein, and it's very tough, and so it replaces the really the inside of the cell, the living cell, with this protein keratin. Some common disorders can occur as far as associated with. So this is as a result of blistering, as a result of some type of irritation and friction on the skin that causes separation between the layers of the skin, which will in turn allow for then fluid to be present, right? Acne, we have inflammation and some minor infection present within the hair follicles at the root of the hair. Cold sores as a result of a virus. Vitiligo you've probably seen as far as white patches on the skin. So where there's no more pigmentation left in certain areas of the skin, and that's when it's pronounced when you see it on someone with a darker pigmentation of their skin, but also people that are very light skinned or would be considered quote unquote white, right? You know, like this, whatever the pigmentation, this vitiligo can occur, but even in light skinned people, we can still see these areas of no pigmentation whatsoever, and it really does look like white patches. Different types of cancer, squamous cell and malignant melanoma, these are both cancerous processes that occur and that can be slow or fast moving, and the malignant melanoma can lead to death. So that's something that is skin cancer that can, if untreated, can lead to catastrophic circumstances. What causes? Yes, so Roxanne, I would tell you that vitiligo is an autoimmune disorder. So do we really know why? No, we don't. We don't have an etiology. We don't have a cause, right? But we can say that it is an autoimmune disorder. So it's actually that your body is actually destroying the melanocytes. It's destroying the melanocytes, which can affect the pigmentation. Let me show you an image of this so that you'll get a better picture. yeah, so you'll see here that there are different levels of pigmentation, but you can see that in case of anyone, right? So here's someone of a lighter pigmentation in their skin, yet you can see this vitiligo is present, right? The white patches where there's no pigmentation. Here's something else I would like to show you since we're here, and I'll step away from this for a moment. So this is called epidermolysis bullosa, or EB, okay? And as we're talking about the integument and such, I wanted to share with you a disorder that's really a very sad disorder. And these little people, these young people, they're showing you pictures of young people because people don't usually, there's one type of EB that they can live to adulthood, but primarily they die when they're quite young. And so you'll see these children here with issues with their skin. They call them butterfly children because the skin really, it's a connective tissue disorder, and it can affect the ability for the epidermis really to anchor to the dermis, to the second layer of skin. And it can lead to all kinds of issues, as well as leading to death because of skin cancer. Okay, it's really a sad disorder, but this is something that, there are quite a few people in the world that suffer with this, and it's really tragic. Deborah is an organization that works to help with families and children that suffer with this type of disorder and looking for a cure. So I don't know if you've ever heard of EB before, but yeah, so I just wanted to give you, since we were there, show you both of those disorders so that you have a little bit of a picture. And again, that EB disorder is really quite a sad disorder. So homeostasis. Now we're going to get into looking at body systems and such, and I showed you those body systems. So you should know like the organs that could be a part of each of those body systems, as well as a basic function of what goes on with those body systems. When it comes to homeostasis, it's a matter of all these organs present within the body systems, right, within the organ systems, that work together in order to maintain a stable environment within, no matter what's going on outside of our body, okay? So this morning there we have snow, right, and it's cold outside. It's pretty cold outside. So no matter how cold it is outside and how wet it is outside, our body will still maintain its proper levels of say, like our heart rate, our respiratory rate, how we breathe per minute, our blood pressure, right? Levels of sodium ions and potassium ions, all these different chemical combination, chemicals that are present within our body have certain ranges where they need to be at in order for you to be healthy and for there to be balance. How about blood glucose, right? So all of these things, and this is just a few things that I just threw out at you, they're called variables that the body will maintain at a very, so think of case of, say, your blood pressure. So 120/80, that was like the classic where they would keep you at, they would say that's within normal limits. They even like to keep you at like lower, like 110 would be better, over, lower, below 80. But so let's just give 120/80. And now a little bit above, a little bit below, that would be like considered a range, a healthy range. But the 120/80, we would say, is like the set point where we would want your body at. So the body will do all that it can with the organs present within the organ systems to maintain that proper healthy 120/80 blood pressure. And we'll talk about that more when we get into the cardiovascular system. But know that it's multiple systems that are working to maintain that blood pressure. Okay? So you'll see here it's talking about different fluids and concentrations. So each cell engages in activities to ensure its survival and helping to maintain this homeostasis, this body in a stable condition, no matter if it's hot or cold outside, whether it's dry or wet, whether it's high pressure, low pressure. That's what's going on in the body. So the body has these receptors. So sensory receptors, meaning it's receiving input. It's going to send this input, send the signals, input, detecting a stimulus, to the brain, right, the integrator. The effector will then, the brain will decide, well, what do we need to do in order to control? So let's say your blood pressure. How do we control your blood pressure? So we're going to send information to the urinary system, and we're going to send information to the heart and such. And so we're going to send information to the blood vessels of the body, whether it's too high or whether it's too low. Okay. But that's how it's receiving input. The sensory receptors are sending information to the brain, and then the brain will determine, well, what do I do with that information in order to maintain homeostasis, maintain a stable environment inside, no matter what's going on outside of the body. So the brain determines if difference exists between how the body is currently operating from how it should be, right? So whether it's, are we at 120/80, or hey, maybe we're at 140/90 or even higher. How do we do something in order to, the body needs to do something to lower that pressure to the normal limits where it should be. Now, when it can't do that, so then patients are on blood pressure medication in order to artificially induce the body to lower that pressure to where it should be. That's just one variable. So you'll see here, but the brain allows addiction, right? Yeah, Roxanne, isn't that, and that's an upsetting thing, is that unfortunately the brain, there are certain chemicals or certain ways that are stimulating the chemicals within the brain that will say, hey, I want, you know, whether it's a sexual addiction, whether it's a caffeine addiction, or a you know, illicit drug addiction, or a prescription drug addiction, or an alcohol addiction, right? There are many things that can really hijack. What addiction does is it hijacks the brain in order to, because the brain likes the chemicals that are going to make you feel good, and so these chemicals, these artificial stimuli, whether it's chemicals or whether it's visual, is like or some type of act, like a sexual act as far as sexual addiction, that will stimulate the brain to release chemicals that make you feel good, and you're like, hey, I want more of that. And so we can talk a little bit more about that when we get into the nervous system and such. This is just giving you a presentation as far as where are the sensors located, those sensory receptors. We know where the brain and the spinal cord are located, and then muscle glands and such are what's going to be affected in order to make some type of change to maintain that homeostasis. So what I've been describing to you then would be really negative feedback, meaning that this is the way that the body will return these different levels to their original healthy, normal state, right? So 120/80, that would be a variable that's in the, we would call it, it's called the set point, right? It's just the area where we're going to return the body to, that's healthy, okay? If it goes up high or if it goes low, the body will use negative feedback mechanisms in order to bring it back to that 120/80, okay? That's called negative feedback. It alters the condition, the external or internal environment, to counteract the change, right? If the change made the blood pressure go up too high, or if the change made the blood pressure go too low, negative feedback will try to bring it back to 120/80, right? Bringing it back, whether it's, like I said, it's always going to return it back to, try to return to normal levels, right? Positive feedback is a mechanism that really is not healthy within the body, other than the case of childbirth and the case of stoppage of bleeding. Okay, so if you cut yourself and you start bleeding, you cut the blood vessels and such of your body. In those blood vessels, there are thrombocytes or platelets, and these platelets will go to the damaged area that there's a cut in order to stop the bleeding. And what happens is that so initially there's some platelets that go to the area. That area that's been cut will send chemicals out, which will attract more platelets to the area. And then as the more platelets come, it'll continually attract more and more platelets to the area in order to block up and stop the bleeding, okay? So that's in case of, look at here, intensifying a change from an original condition. So we're taking just low level amount of the platelets to, we're having more and more platelets come to the area. That's a case of positive feedback in a healthy way, healing of a blood vessel that's been cut. In childbirth, very similar. We start with contractions that are light, and they get stronger and stronger and stronger as a result of chemicals being sent from your brain to the area of the uterus in order to contract. They get closer, the contractions, and stronger in order to birth the baby. That's also a healthy mechanism for positive feedback. And then it stops once the baby's born, other than you also will deliver the placenta. Okay. So here's just giving you a little bit of a information regarding what's taking place here. Is progesterone? No, it would be oxytocin. Oxytocin is what's being produced, the hormone that's being produced that will increase the contractions, will stimulate the contractions. Progesterone is really a chemical, and we'll talk about this, a hormone that's used to maintain its pro-pregnancy. Okay, gestation is when the child is forming within the womb. So we just found out good news this past weekend that my oldest daughter is expecting for the first time, and so she's very early on in her first trimester. But yeah, so the progesterone is being produced at a higher level in order to maintain the uterine lining, so that the egg is now this little embryo, it's a person, folks. It's not going to turn into anything but a human. Is now implanted in the uterine lining, and we need to maintain that thick uterine lining in order for this little baby to develop and such. So quite exciting. So let's see here. Hey, thank you guys. Thank you very much. Yeah, we're very happy. So homeostatic feedback, for negative feedback, in order to maintain your body temperature. Okay. So you'll see here that there's a range, right? There's a range in body temp. So we would say that, so really like 98.6 Fahrenheit, right? This is centigrade. Fahrenheit would be what the set point was for many years. We're seeing now that really, and even as you get your temperature taken when you go to any type of facility. In the case of our school, anybody that comes on campus has to have their temperature taken. And you'll see that many of our temperatures are lower than 98.6. They're like in the 97.5 and a little bit above that area. So over a time, back from like the 1860s, when we determined that 98.6 was the Fahrenheit was the temperature that many humans had, it's lower. Okay. And there's different factors regarding that, and we can talk about that a little bit later. But know that we are, as a result of our body doing its functions, when you just move, when you're contracting your skeletal muscle, that creates heat. And that also is one aspect of what's maintaining our internal body temperature. But there are other metabolic processes going on that contribute to it, in addition to muscle contraction. Okay, but this is the range. So we say that centigrade, so 35 to 41, that's the range. It's a healthy range. Now, if the temperature goes up a little bit higher or a little bit lower, via the negative feedback, it will then bring it back to that healthy range. Okay, as a result of, so say if the temperature goes too high, so say it's greater than 41 degrees, say it's 42, 43, 44 degrees Celsius, right? So as we get higher, really like 42, 43, really like it's getting high, and we need to do all that we can to lower it. So what we're going to do is we're going to then, the body will sweat, right, in order to, via evaporation, decrease the temperature, as well as vasodilate, in order to have the blood vessels expand, allow more blood to the surface of the skin. Your skin gets red. So when you're exercising, don't you get a little flushed? That's as a result of this vasodilation. That also will help to decrease the heat. So in the case of sweat, right, it's going to evaporate and allow for cooling to take place. These are conditions that occur: exhaustion, stroke, and hyperthermia. These can all be issues where, folks, it can lead to a heart attack, a stroke, and death, right? So we need to be careful as far as when we're in a very hot environment, that we're doing all that we can to hydrate and stay in the shade to kind of cool off a little bit. I'll tell you something. It's kind of weird, right? Interesting, or just something to think about. In the case of geriatric patients, older patients, right? Their mechanism for cooling, as far as also their ability to feel chilled and such, is different. So if you've ever been to a nursing home, or you've ever been to a grandparent's home, grandparents' house or older person's home, it might be a little bit warmer in there because they like it warmer because they're feeling a little chilled, right? Now, what will happen is that during the summertime when it gets very hot, in some instances, older patients might have a fan on, right? They might have a fan on, but they won't put the air conditioning on to cool the room. They'll just have the fan blowing. Well, there's something called, so when I cooked professionally, we used convection ovens. A convection oven is heat as well as air blowing into the area where you're cooking. So there's this forced hot air blowing, cooking whatever it is that you want to cook. And it cooks it quicker as a result. So imagine you're in an apartment or some type of home where the heat, it's very warm, and then we have a fan blowing, but no air conditioning, just a fan. You're creating like a convection oven type of a situation. I'm new to this. Right. I'll answer your question in just a moment. It's a little bit of a long question. I couldn't finish reading it, but when I stop this PowerPoint, I'll answer your question. So you'll see here as far as changes in temperature and what's taking place. I'm not asking you to know all of this, but just it's very interesting to be able to see how the nervous system receives information, right? And then is able to then make determinations on how to make change in order for the patient to be healthy. So in the response to cold, it's opposite. So instead of that vasodilation, those blood vessels to expand and have more blood to the surface of your skin, vasoconstriction, they're actually narrowing, okay? So the whole, so when I think of a lumen, I think of, so look at my paper towel roll here, right? And it has an opening inside there, right? So we would say that if this represented a blood vessel, this could be the inside of the blood vessel. Vasoconstriction, it gets smaller. So it becomes narrower, right? And that lumen of the blood vessel becomes narrow, and it allows for then the ability then for that blood to be shunted to areas like the brain and like your heart, areas more to the core to keep you warm. And this is why like your extremities can get, your hands, your feet can get cold in response to very cold outside. The body wants to make sure that it's warming up all your important organs as well as your brain. Okay? Shivering is also an aspect, as well as your hair standing up on end, right? That's kind of a wild thing. These are all matters of trying to warm yourself in a cold environment. And know that just as hyperthermia can be very bad and detrimental to your health and could lead to death, hypothermia can also be fatal. And here you're just seeing a table to describe to you the what goes on as far as the negative feedback, bringing it back to normal would be present, whether it's if it's too cold or if it's too hot. And this is just showing you too here as far as I would imagine this hand might have been placed in ice water and then taken a picture so that you can see the difference as far as the heat being present as far as the heat signature. Dry throat today, I apologize. All right, so that would be chapter 4. So again, like I said to you all, that quiz will be available from Thursday until Sunday evening. Okay, so until Sunday evening, you have that time to be able to do that. Okay. Now I'm going to show you that I didn't put in the coursework yet, and you should be looking in the coursework as far as things that you'll need to do, different types of homework and so on, assignments that you'll need to do. I'm adding this assignment for you all, and this is already posted, and I'll make this available. It's in documents and resources for the new chapter, chapter 5. On the, let's see, I think I put it. On the 19th, here we go. Actually, no, on the 21st. So I'm going to have you define all these terms. You'll create a Word document. You'll define these 25 terms, and you'll create a Word document for it, and you'll upload it into coursework. I'm going to post it a little bit later on today, and it'll be due on the 21st. Okay, so it kind of forces you a bit to take some of these terms, this terminology here, and to to review it, go over it, define them, and then these are going to be used also within your quiz for chapter 5. So your first quiz, it's every week you have a chapter quiz, right? So this way you're staying current, you're not having to memorize and work on studying multiple chapters. It's just one quiz per week per chapter. So chapter 4 quiz, again, this Thursday to Sunday to be available. This coursework, I'm going to put this in coursework. This assignment, again, it won't be available. It won't be due until 11 days from now, okay, the 21st. Today's the 9th. Okay, so you'll see the details and I'll give you the information. You read the assignment in coursework and it'll tell you exactly what you need to do. Okay, let's see. So now what we're going to do is we still have some time. So I would like to go into chapter 5 and we'll continue with chapter 5 on Thursday. So I'll send you another GoToMeeting invitation for Thursday at 9:30, and I'll review with you the integumentary system as far as the image that I'd like you to study for your lab quiz that'll be coming up within a few weeks. Okay, and then I'm going to show you here as far as we'll finish up chapter 5 PowerPoint. Oh, I want to address the question. So let me stop sharing for a moment. Okay. So Ashley asked a question. I'm new to this. Yeah, so Ashley, really when I'm doing these GoToMeetings, it takes the attendance for me. Yeah, so then I just take it over to, so it just takes the attendance for me. Okay. So yeah, you're good. And you read through the syllabus, look at the syllabus. It's posted in the syllabus region of our class. And if you have any questions, send me an email and I'll help you any way I can. So now we're looking at this special system, chapter 5. This would be the skeletal system. So again, we started at chapter 4. We didn't start at chapter 1 in the textbook. You can look at 1 through 3. But we started at chapter 4. We just finished that up. Now we're looking at chapter 5, the skeletal system, and we're going to be focusing on each week there. We're going to be looking at different body systems, organ systems, and what they're comprised of. Okay. So again, your quiz will only be on one chapter, unless I say otherwise, but it's only going to be one chapter. Okay. So let's go to slideshow here. And we're looking at the skeletal system, and you all have a good idea as far as what's comprised of the skeletal system and kind of what the functions are and what it does as far as allowing for an anchor for the skeletal muscle, those muscles that move the bones, right? It allows for an anchor for those muscles in order to be able to contract and move the skeleton. It also allows for a protection of the organs, the important organs of our body. And it also allows for production of certain, like a bank, say, and for calcium. Calcium is a very important mineral that really is present in the nervous system as well as the muscular system in order for them to do their functions. And we'll talk more about that. But the body needs a lot of calcium, so that you know that. Okay. And also, not only just that, but it also produces blood cells. Okay, so the skeletal system will produce in the red marrow in particular. Their yellow and red marrow, we'll look at that. But the red marrow produces blood cells that are present within the cardiovascular system within the blood. Okay, so we'll look at that. And so you'll see here, as far as the bone is considered a type of tissue that's a connective tissue. Okay, it's comprised of living cells that are within a special matrix. So it's not like the epithelial tissue that has these tightly packed cells, different, right? These cells are present in more of a diverse mixture of different types of chemical and different types of proteins and fibers and such. And you'll see that here as we look at it and talk about it, that these cells are present. So they're not all tightly packed together. It's different. The periosteum has 2 layers, and this is the outer covering of bone, okay, the periosteum. So there's an outer covering that's like this dense connective tissue that's protective, and then the inner lining of the periosteum is what really will produce have these bone cells, these osteoblasts, that will produce other types of bone cells. So the osteoblasts and the osteocytes, when we think of a cell that actually is synthesizing and creating, we think of osteoblasts, okay? Secretes collagen, elastin, carbohydrates, proteins, right? Very important type of a cell, producing other types of cells also. Osteocytes are mature bone cells. So when we think of a mature bone cell, we're looking at bone that's been around for a bit there, and whether it's the compact or the spongy bone, there are two different types of bone. These osteocytes are the mature bone cells. So here's that term, compact and spongy. So when you think of a sponge, you think of a structure, something that you're holding onto that really has holes present within. Okay, these holes present within are really allowing for that what I talked about before, as far as the marrow, whether it's the yellow or the red marrow, they're present really in that area of the spongy bone, and also in an area side of the compact or outside of the compact bone. That's a better way to put it. Yeah. But I'll show you where it would be located within like a hollow. So think of like long bone here. So I have my radius and my ulna, my humerus, or you can think of the femur, your thigh bone, right? They're considered long bone. Well, within the long bone, within the shaft of that long bone, there's an hollowed out area. That hollowed out area will contain also marrow. Okay? So the compact bone really is what it says. It's compact, it's dense, very solid. Spongy bone, right? Lacy, has holes, right? These holes will allow for that part of the special type of marrow to be present within. But it's still firm and strong, right? So even though it's spongy, even though there's still holes present, it's still firm and strong. So you'll see here, I'm showing you right here, right? This would be a femur, okay? And what you're looking at here is if we cut it open and we see that there's this inside portion, that's that cavity that I mentioned about where the marrow could be present. And this would be considered compact bone here, very tough, durable, dense bone. Here's that spongy bone, right? Spongy bone is present, and we have this marrow present within the spaces of the bone. See right over here? See how there's spaces? It looks like lace. It looks like almost like a lattice. You know, lattice would be, say, for under a porch, lattice work on a home. That's what you're looking at, these rods of bone with spaces. So there's marrow present. There's also blood vessels present. And even in this dense compact bone, okay, what you have going on here, folks, is that you have, here's openings, see a little big circle here? Okay, that's that circle right here, and you're going to have blood vessels, you're going to have nerve, you're going to have lymph that are moved within this very dense tissue. Now, it's that you can see all these little dots, those represent spaces where cells are present, okay? Right, so you see all these black dots. So in those black dots, it's a space, and there are cells present within. But know that it's still not as compact as, say, the epithelial tissue. Let's take a look at that for a moment here again and see. So in the case of epithelial tissue, as you're looking at these examples of epithelial tissue, this is all cells. These are all cells. So the tissue is comprised of tightly packed cells, right? And here we would have examples of the types of tissue present within the human body. These are slides that we've made of these types of tissues, right? And so you see how they're all tightly packed cells. It's much different from the case of this compact bone. Even though you can see a lot of cells, they're not all as tightly packed as, say, that epithelial tissue would be. And when I'm looking at this under the microscope, as far as compact bone, it looks like a tree trunk that's been cut, doesn't it? Yeah, that's what it looks like to me. And so you'll see here, this space this is a canal, this is an opening where we have these blood vessels, these lymph vessels, nerve would pass through. Okay, so when you fracture a bone, does it bleed? It does, because it's highly vascular. There's a lot of blood present within bone. Okay, and again, bone, hard tissue. Sorry, I shook my camera there. It's hard tissue, but it's living tissue. So, and it's continually being remodeled, repaired, replaced. Okay. So you'll see here, and let me show you back on this image here. You see this this line right here, right? So this is the area where bone, long bone, would grow in length. Okay. So really, what happens is that there is cartilage present here in a young adult, in a young person, child, right? Infant, child, until they get to puberty. After they stop growing, that gets replaced with bone. So there was cartilage here, while you're growing. That's called the growth plate. You've probably heard that term, growth plate. And the growth plate has cartilage. It turns and it allows for a bone to again grow in length. And over time, as we hit puberty and as we stop growing, that becomes bone instead of replacing where their cartilage was present. So the ends of bone, this would be the epiphyses. The epiphyses would be plural, epiphysis, one end. So here we're looking at, now this would be the case of an infant, right, that's not been born yet, right? So we would say the child, another term we use would be embryo and then fetus and such, right? So these would be terms describing the child that before they've been born, called preborn, right? They're not been born yet. Their skeletal system starts out as cartilage, and the cartilage gets replaced with bone. Okay? So cartilage is like the model upon which the skeletal system will be produced primarily. Not all, but primarily. Like the flat bones of your skull, a little bit different. It's called membranous formation of bone. But this would be endochondral formation of bone. Okay, so as you're seeing here, this cartilage model gets replaced with bone. Okay. Now the term remodeling. Remodeling means that your bone is in a continuous state of change. Okay, so bone is produced, bone gets old, right? It ages, and then it gets replaced with new bone. Okay, so that's that term remodeling that we would use. You remodel the home. So I remodel my kitchen. I take the old kitchen, remove it all. Takes a little bit of time, but you're able to piece by piece remove it. And so in the case of your skeletal system, you're not removing all of the bone at once, or else there'd be an issue. But areas of the bone over time get replaced slowly, and then replaced with new bone. And remodeling the kitchen, you put a new kitchen in, right? Different structures and cabinets and whatever have you present within the flooring, right? So that's remodeling. That's taking place within the skeletal system. Okay. Oh, sorry. You'll see here, bone is subjected to mechanical stress, and by this stress, meaning that if you put so think of weightlifting. That's an easy example. I have a weight in my hand, and I'm lifting this weight, and not only am I increasing the strength of my muscles, but I'm also increasing the strength of the bone by putting stress on the bone, because I said bone is living tissue. So as such, if I'm exercising, if I'm weightlifting, I'm not only increasing the strength of my muscles, I'm increasing the strength of my bone, and so the bone gets stronger, it gets thicker, it gets stronger, and it's able to handle more things. So in the case of those guys who are strongest men athletes, right, and women that do strong type powerlifting competitions and such, right? Not only could I not just go and pick up a weight that's a very extreme weight that they can handle, right? Not only are my muscles not able to handle that, but really bone can actually fracture as a result of holding on to heavy weights, right? And there's even videos of people have posted online about gym injuries, and it's whoa, yikes, why would you want to watch that? But anyhow, it's there. It's the internet, that's why. So more bone is being deposited, right, and synthesized and created than removed. That's creating stronger bone. Okay? And so really, Bone remodeling helps meet the demand for dietary calcium. So we need to intake calcium into our bodies as far as nutrition, as well as when we're taking in whatever food substances we're taking in, we can then take those and then be used by and stored in the skeletal system in the bones. So you need to know that the skeleton is comprised of 206 bones, that there are red and yellow marrow. Now, so know this here, folks, right? That it says red marrow in children, yellow marrow in adults. Well, adults also have red marrow. They just don't have as high a percentage of red marrow as the children do. So the children also have yellow, right? And know that this type of marrow, this yellow marrow, if an adult needs more red marrow, it can convert this yellow marrow to red bone marrow. The red bone marrow is producing blood cells, very important for the function of the human body. Ligaments and tendons, very important as far as ligaments and tendons allow for your bones to stay tightly together, as far as a ligament will connect a bone to bone. Tendons anchor or connect the muscle to bone. Okay, that's kind of a weird thing, indeed. Yeah, I don't know. I'm not familiar with that. No, it's okay, Roxanne. I'm not familiar with that, but that's kind of strange for sure. Tendons, again, anchoring the muscle to the bone, allowing for the muscles to be able to move the skeleton upon contraction. So here you're seeing, and really, when you're looking at an adult, in this cavity right here, right, this cavity will contain yellow marrow, and in the ends of the bone will contain red marrow, right? So red marrow, yellow marrow, okay? And that yellow marrow, I didn't mention this to you before, but I'm going to say that to you now. It's adipose tissue. It's the storage of fat is present in that yellow marrow of the bone. Now, as we're looking at this image here, so red marrow, the flat bone of the skull, the sternum, the pelvic, the coxal bones, right? The ends of long bones will contain red marrow and contribute to the production of blood cells. So you'll see here, you should know this, important as far as whenever we discuss any type of chapter present within the this book, as far as the different systems, as far as the body systems, cardiovascular, right, integumentary, you need to know the basic function of each of these systems. And so here we're giving you as far as functions of bone and the skeletal system, allowing for movement, allowing for support, protection, mineral storage, right? I said to you that bones are a reservoir for calcium, and I didn't mention this to you, phosphorus also, okay? And then blood cell formation, as I mentioned to you before. Okay, go a little bit longer. And here you're seeing as far as, and you need to be able to, with this chapter and with our lab, you'll need to be able to know the bones of the human body, right? That we have the skull, that we have the sternum, right? The ribs, there are 12 pairs of ribs, right? 12 on this side, 12 on this side. So they're bilateral, they're on both sides. This is the femur I mentioned to you earlier. Here is, so the thumb side, we have the radius, the ulna, the humerus. Okay? Now know that when we do our lab, you'll have a word bank. You'll have these words. You'll just have to remember where they go on your identifying an image. Okay. So I do provide the word bank for you. You don't have to just memorize the word per se, but you still will need to know where these different bones are located in the body and what their names are. And again, I'll provide that word bank. And in the case of like your quizzes, it'll be multiple choice. Okay. So let's see here. We'll go just another minute or two. Okay. So the axial skeleton, the bones that make up the body's vertical axis. So look here, the skull, right? The bones of the skull, the backbone, your vertical column, your vertebral column, your spine, right? So here we have different bones of the skull. Okay. Again, you'll have a word bank for these. There's a few of them. The frontal bone, when you think of your forehead, that's what you think of the frontal bone. Now, here, folks, right? This is the nasal bone. This is the bone right up here. Not all of your nose is the nasal bone, right? Because there's flexibility, there's cartilage present. Here's your temporal bone, which would be where your temples are, your parietal bone, right? And your occipital bone. If you put your hand at the base of your skull, that's your occipital bone. This is pretty cool. This is the external auditory meatus or acoustic meatus. This is the hole where inside of there would be the structures for your sense of hearing. Here we have the opening. So this area would be filled in by cartilage for your nose. So if we go deep within that hole there, that's your nasal cavity. Here is the orbital cavity for your eyes. Here we have the upper part of your jaw. And so that the maxilla doesn't move, but guess what does move? The mandible. So it's a hinge joint. You see this right here? So it's just moving, opening and closing, and pretty neat. So very important that there's special cartilage in here that's present within between the spine, bones of the spine, the intervertebral discs. It's a special type of, it's called fibrocartilage. It's present there and also for your TMJ. You've heard that term TMJ maybe. Temporomandibular joint, temporal mandible, right? Mandibular joint, that's right here, okay? You can actually, if you take your fingers, take your index finger, this is actually number 2 finger, you put them inside of your ears and open your mouth, right? So open and close your jaw. You can actually palpate or feel the bones moving in that joint. All right, folks, we're going to stop here today and I'll stop the recording. So have a great day